Hello everyone, I'm Jung-Cheol. Now let's begin part 3, the examples, chapter 10, Iptables examples. Okay, number 1, set the default firewall policies. In the first video, I already explained about the policy. So the Linux Firewall, the Iptables has a policy, the default policy. At first, if you start normally, the policy is accept, but here we will change like this: input drop, output drop, and forward drop. This one can be a kind of the default firewall policy. But number 2, only block the incoming traffics. So here, even if the input drop, forward drop, but output is accept. In this case, normally we can drop all the incoming packet forward also, but allow only the outgoing traffics. Number 3, drop private network address on public interface. In my case, now I have, for the testing machine, there are two the network interfaces. So ETH1 and ETH0 is can be a kind of the public interface to connect it to the internet. But ETH1 is the internet network. So in this case, maybe, for example, 192.160.0.0 and 172.16.0.0 and the 10.0.0.0 is normally this kind of IP address we can say the private network address. So this kind of private network address cannot access or cannot be used in the internet. So in this case, we have to drop this kind of IP address where the public interface. Number 4, block the outgoing IP address. So even if you already accept the output packets, but in this case, destination address and the destination address. So, and when we define or decide exactly what the specific the destination IP address for the output chain, then we can drop like this, drop. Number 5, the block will allow ICMP ping packet. So if we use the default policy as a drop, then all ICMP packet will be dropped. But here, first one, Iptables, the ICMP message echo request. So according to the message type, we can drop like this. But number 2, Iptables input. So input, in this case here, source address 192.168.0, this source address and the ICMP packet echo request will be accepted. Or even if we just blocked all the ping package to use the ICMP by the default policy drop, but here ICMP echo reply and the destination unreachable and echo the request ping, this one will be accepted. Number 6, open the range, the port and IP address. Iptables input the state, the match state, and the due, and the protocol TCP and the destination port here 7002, 7010 will be accepted. So when we configure the range of eject port numbers, then we can use the colon like this. The next one, Iptables -a input the TCP destination port 80 web server and the match IP range source address range 192.168.100 to 200, then will be accepted. In this case, if we want to configure the source address range, then here we can use hyphen like this. Number 7, block or open command server port. So here we will open the SSH service, DNS, email, HTTP, and HTTPS. In this case, if we want to configure using one sentence or one node, then we can use this option, the match option, multi-port, and that destination port 22H, 2553, 110 POP3, 143 IMAP, and 443 for HTTPS. Also, we already opened this kind of port using for the input chain. Also, output chain must be open. In this case, source port will be like this: 22, 25, 53, 80, 110, 143, and 443 like this. B, allow time synchronization using NTP. Normally, NTP network time protocol use port number 123. So in this case, we have to write this. UDP destination port 123 must be accept. Number C opens access to Samba file server for LAN users. Here, in this case, the source, in my case, I'm using this 192.168.0. And the destination port will be 133, 38, 39, and 445. D, open access to MySQL and Oracle server for LAN users. In this case, the 192.168 will be the LAN users, and the destination port is 3306. This one, the MySQL. And the destination port 1521 is Oracle. Okay, then let's test here. Okay, now in my case, now the server part, now the input drop, forward drop, and output now accept. Okay, so now let's test number 3. I can already copy like this. So copy, paste, and after that, let's check. Already the input policies drop. Also the rules for the target. This one, source address. This one, this one, this one. Now already drop like this. Okay, number 4. If we want to drop the exact the IP address, even if the now, okay, so now output chain is accept, but if we use this one, so now even if output is a policy is accept, but this IP address destination and this one will be dropped by this rule. Okay, then number 5, block or allow ICMP ping packet. So now already we are using the input here, the policy should drop. So let's test here. The from client ping server. So now 85 is a server, but according to this rule, this policy now this ping packet will be dropped. So here let's add so now here accept ICMP packet from the source address here. Okay, then now is a ping packet from the client to server is successful like this because of this rule. Okay, like this. And except this one, also we can add this kind of copy the ICMP messages. Okay, fast also. So Iptables okay, so now we can see this kind of ICMP type is the messages, means the messages. Okay, and after that, now the port range and the IP address range. Copy, paste. So now you can see first one, the destination port range 7002, 7010, and the IP range 192.168.81 to 200 will be accepted to the port number 8 web servers. And number 7, open the SSH DNS email HTTP and HTTPS using input and output chain. Okay, copy. Okay, the paste. Then you can see the multi-fault here like this, and the outbound also accept like this. And okay, NTP network time protocol also copy, paste, and Samba also. Okay, Samba copy, paste, and after that database server also MySQL copy, and Oracle as well. Okay, then so now we have this kind of rules, especially the 22, 80, 25, 53, 143. Let's test again. This is a client part. Okay, SSH server. So now I access to the server using SSH service. So because of this rule, multi-port 22 mean the SSH, but for example, now in the server part, I have a telnet service also, but the telnet server now cannot access because no rule to accept the telnet service. But I table already. Sorry. So now I already accepted the 22 SSH service, but that will be fail. Okay, and after that, okay, then, okay, let's test the number 7. Okay, next one, number 8. Restrict the number of parallel connections to the server per client type. For example, here, number 8, allow 3 SSH connections per client host. So in this case, the destination port 22 and the connection limit above 3. Maybe if the SSH connections above 3 will be the reject, only the below the 3 will be accepted. Number B, set HTTP request to 20 for C-class network. In this case, destination port to web server and the connection limit above the 20. Then will be the drive, especially this one 24. 24 means the connection limit mask 24. So in this case, the group host. So maybe if one the C-class network try to access the web server, but the connections is over 20. In this case, will be the drop. Number 9, the load balancing incoming web traffic. So in this case, we can use the match option here. Okay, the static and the mode NTH every 3 packet. In my case now, I have the 3 kind of the servers for the web. Okay, here 85443 mean HTTPS, 192.86 and 192.80.7. So I have this kind of 3 the web server, especially HTTPS, and normally these 3 web servers support what? Here the load balance using Iptables. So first packet here, first packet will go to here, and the second packet will access to this one, and the third packet will be the transport to this one. So this rule normally support the load balancing for web servers for the 3 packet. Number 10, prevent DOS attack. So DOS attack means you normally use many kinds of the packet for the specific server to shut down their services. So in this case, for example, TCP destination port 80 limitation, the match limit, so 25 per minute, limit burst 100, J accept. It means only if the total the packet numbers reach to the 100, and after that, per minute, only 25 the connection will be accepted. If the this kind of connection is a reach over 25 per minute, then this one will be the drop. So using this kind of rule, we can protect your service from DDoS or DOS. Number 11, port forwarding. Okay, in this case, now the 192.168.85 is the server, and destination port 422. In this case, in this case, this kind of packet will be forward here, 192.168.85, port number 22. And after that, in the input chain, we have to permit this kind of state, new, established, and accept. Output also must be the permit using this one, the state established. In this case, we can support the port forwarding using IP tables. Number 12, the log drop packet. This kind of normally rule must be, even if we can configure this kind of rule, but this rule should be at the bottoms. For example, first one, Iptables -n login. Then this one on the n mean the new. So now we can create a new chain, the logging. Its name is logging. And after that, number 2, input j the login. It means all packet to input chain will be jumped to the logging. And after that, number C, Iptables the logging, the limit 2/minute j log prefix Iptables the packet drop and log level 7. It means if some packet is reach to over 2 per minute, then this packet will be the logged using this kind of message Iptables packet dropped. And if we want to drop this kind of the packet, then Iptables login drop like this. 13, the log errors. Normally, Iptables support the connection tracking here like this, but when we use this kind of connection tracking module by Iptables, you can see some the error message like this. Table 4 was dropping the packet like this, where in here, log message. In this case, we need to extend this kind of the connection trackings, the module numbers like this. So using this one, sysctl or sysctlw, then you can extend the connection tracking maximum here like this. Or if you want to check the maximum connection tracking rule here, etc sysctl com, then here you can change exact the numbers. Number 14, the NAT, the examples. First one, IP masquerade. In my case now, I can guess like ETH0 internet, the external connection, and ETH0 is the internal connection. So in this case, first, echo 1, the proxy sysnet IPv4, IP forward. So using this one, we can support IP masquerade using this one by the forward chain. And after that, IP forward, the Iptables forward, the ETH0 means the external accept, and ETH1 also accept this one internal. And after that, using NAT post routing ETH0 means the external j -j the masquerade. Then this the internal network to use the private IP address can access to the internet. B, the SNAT, I mean the source NAT. Normally, source NAT can be used from inbound to outbound. In this case, normally inbound means the private IP address, and outbound normally use the public IP address. For example, Iptables NAT, the -a post routing -0, the ETH0 -j as NAT to 200, 100, 100. So here, 200, 100, 100 IP address means the public IP address can be used to the internet access. But the inbound here, inbound network normally can be as a private IP address. So in the internet, only in the internet, this IP address can be seen by the users. But in case of this one, normally we can guess the forward is the accept. But if the forward rule is dropped, then we must use this kind of rule as a forward, the ETH0, ETH1, and the state, border state, new established rate must be the accept like this. Destination NAT, normal destination NAT means here the outbound traffic to inbound traffic. Normally in this case, outbound traffic is our use the public IP address, but inbound normally we use the private IP address. This kind of the rule can be used in the DMZ. For example, Iptables NAT, the pre-routing, the ETH0 means the public IP address can be used to the internet, and source port here 1024 to 65,530. Normally this kind of port can be used for the client, and the destination 200, 100. This way, so our the public IP address, and this one 80 means the web server. In this case, this kind of packet will be forward where this one 192.168.85.80. This one is a private IP address as a GMZ. So this one, all the packet to this public IP address and destination port, this one always will be forward here. Iptables forward, and after that, the module state established related these kind of things must be accepted as well. And one more thing, the outbound traffic from the source port here 1024 : it means 1024 to the last port number. This one is the same, and the destination 192.85, destination port 80, then this one must be accepted as well, because this one is a kind of this one private IP address as a DMZ. Okay, then let's test this one too. Okay, first here let's take tables. So I have this kind of rule. Okay, then let's test number 8. Okay, first one, Iptables for the copy the SSH connection. Okay, paste. Okay, and after that, web server as well. Copy. Okay, paste. Okay, then error. So now we can see this kind of dual rule. Okay, here in the inbound traffic. So like this for the SSH and for the web. So we can see. So for in case of the SSH is using the host IP address, but the web server is using the 24-bit. So the maximum is 3. This one maximum also 20 packets. Okay, and number 9. Okay, let's try to use this one. Copy, paste. So, oh sorry, Iptables VNL. So now we can see the okay, so this one. Now in this case we are using the pre-routing DNAT, So in this case, Iptables NAT like this. So we can see here destination NAT, and masquerade also like this. No, not this one. Masquerade later we will use this one. So here destination NAT. So destination port number 443. So in this case, the first packet will arrive here, okay, and the second packet will arrive this one, okay, 192.168.86, and the third packet will arrive like this. So using this one, we can support the load balance for web servers. Okay, and number 10, the DOS attack, prevent the DOS attack like this. Okay, copy, paste. Okay, so now you can see this one. Okay, limit. Burst 100, the average 24 over this one, then this packet will be the dropped. And number 11, port forwarding. Copy this one. Okay, then paste also. And also this one, let's take first one. Now the NAT and input output. So for the input, okay, this one 422, and the output also this one 422, and after that, so now we can see one more rule. Okay, here 422. This one packet will forward to port number 22 like this. Okay, and after that, number 12, the log. Okay, first copy, let's create, paste, and after that, second, Iptables, copy. All the packet to the info will be jumped to the logging, the chain, the new login, the chain, the logging, and after that, let's try to use this one. And if we have, for example, so for example, now here is a logging new chains and has this kind of rules like this, and this one will be the save to the log file. And if we found this kind of package, so using this one, Iptables logging drop, okay, paste, then Iptables. So now this kind of packet will be dropped like this. Okay, the log errors. Okay, let's check first this one, etc graph. So now in my case, this one. So if you want to change this one, open this one. sysctl comp. So here, in my case, using this file, you can change this number. If you find the error message from the log messages. Okay, number 14, the NAT exam, first one, IP masquerading. So okay, copy. So in my case, now I'm using two kinds of IP address. So ETH0 192.168.85 and one ETH1 192.168.55. So in this case, paste. So now in my case, I'm using the this one. Forward, okay, this one, okay, let's check this one as a forward packet, accept, and not forced routing. So let's check the forced routing. So here the post routing. So we can see this one masquerade or ETG0 like this. And after that, the source NAT, the number B. Okay, let's check first this one. Copy, paste, and after that, P NAT. So let's check the forced routing. So okay, here forced routing, and we create like this. So all the private IP address will be transferred to this one. This one is the public IP address as our gateway. And after that, the destination NAT. Okay, let's test this one. Copy, paste, and let's test first one. Let's take the forward packet. So forward this one. Okay, this one. We can see this one like this. And the second, now using this one forward and the pre-routing. And to see the pre-routing, NAT. So now let's check the pre-routing. This one. Okay, here. Maybe if the source address, if the source, the destination address is the public IP address, then this kind of packet always will be the transfer to here, 192.160, the 86.80, mean the web servers. From this is a destination IP address. So destination IP address means a kind of the official or the public, the web server's IP address, but this IP address always will be transferred to this one, like this. This is a destination NAT. Okay, so far I explained about the IP tables, the example. So this is a summary. In chapter 1, we learned about NAT overview. So NAT is the IP tables is a packet filtering the firewalls. And the NAT filter architectures, we learned about the IP tables, the table, the chain, policy, and the rules. In chapter 3, we learned about the rule target. So here, rule has this kind of target: drop, accept, look, reject, queue, and the return like this. In chapter 4, we learn about chain the operations like input, output, the forward, and the routing and post. And this kind of things is the IP tables is a chains. And chapter 5, match criteria. So to match criteria, we can use this kind of things: protocol, port, interface, limit, time, or MAC like this. In the chapter 6, the directional filtering, so we learned about the inbound and outbound traffics. According to our rule, some packet only can be used on inbound or outbound like this. Chapter 7, UDP and ICMP match extensions. In chapter 8, we learned the connection tracking. Normally we can say stable inspection. So here we studied about the state, four kind of things: so new, established, related, and invalid. And the NAT, we learned about the source NAT and destination. In the source NAT, we can include also the masquerade as well. In the chapter 10, we learned IP tables examples, around the 14 the examples. Okay, thank you for watching this video, and see you next video. God bless you.